Hello, I'm Jason with scienceandmath.com, and today we're going to do a neat demonstration that shows you about carbonation in a soft drink or a soda and show you an easy way to prevent that thing from fizzing all over the place if you shake it up or if you drop it. And so there's a little bit of science behind that, but also something practical that you can use anytime you drop a can of soda on the ground or you shake it up. So first of all, what you'll need for this experiment is a soda can, doesn't matter what exactly kind, just something that's carbonated. You'll need a glass bottle. You don't really need this part, but I'll use it to demonstrate what's going on. Really all you need is a soda can and some kind of a plate or something, or a sink or a basin, just to make sure you don't make a mess. And we always want to make sure we wear our safety glasses as well. So what's going on here? You have a can of soda. We all know what happens if you open these things and pour them into a glass. You start seeing bubbles form, right? Bubbles, you have top full of bubbles, and eventually the bubbles pop, and then you enjoy your soda or your Dr. Pepper or your Coca-Cola or your Sprite or whatever it is. What you have inside of a can of soda is the liquid, right, which is a lot of sugar water really, and then you have all the bubbles. But you notice that the bubbles only really start to appear when you open the lid. Like if you have a glass bottle or a plastic bottle and you open it, then the bubbles will pop out. You see, there's gas that they put inside this can, or inside the liquid in this can, and it stays in the liquid, and those gas bubbles come out whenever you pour the liquid. They also come out if you shake this can, right? So if you shake it vigorously, then the bubbles are going to start to form. If you open it, the can just flies everywhere and everybody gets wet, and it's not fun. So let's sort of show how that's going to look in a clear container. So I haven't shaken this can. There's nothing shaken here or anything like that. So I'm just going to gently try to pour as much of this in here as I can, trying not to let all of the bubbles form, but you can see the bubbles are forming there, like that. So I'll just get the whole can in there. All right, so here we have our liquid here, and inside of this liquid, even though some of the bubbles have already come out, there's still a lot of gas dissolved inside of this liquid. So what's going to happen if I shake it up? So let's shake it. So you can see what happens here. When you shake a can of carbonated beverage, in this case, the top literally popped off of my bottle because it was not on as securely as the lid of a can. It popped it off, the pressure increased, it popped it off, and the thing just went everywhere. And what happens is when you take a can, a regular sealed can, and you shake it up quite vigorously, then what's going to happen is inside of this can, all of that gas that's inside the liquid, it kind of starts to come out and form these bubbles. And it puts pressure on the inside of that can. And so if you pop the lid on the can, the soda goes everywhere. And you can see I just shook this just for a second, and everything just went everywhere, right? So what's really going on is inside of a sealed container, if I were to shake this, I'm going to go ahead and do that right now. You saw what just happened a minute ago. Everything went everywhere, right? So you might think, well, this is a little crazy to do this now. I'm going to shake this guy really, really good. What's happening is there's bubbles that are forming in here. Some of them are forming inside the liquid, and they kind of float to the top of the can. Some of them float, and they kind of stick to the sides of the can. They're sort of like inside the can, just sort of stuck. Like if you think about when you pour a glass of soda into a bottle, the bubbles sometimes form on the side of the bottle or form on the side of the glass. So that's what's happening here. When I shake this up, a lot of these bubbles are forming on the side of the can. Now, a lot of people have told you probably to do something like this to try to take away the carbonation. That sort of works, but what you really want to do is focus yourself on the side of the can. If you can get these bubbles to detach from the side of the can and float to the surface, then you're going to have less Dr. Pepper or Coke or whatever spew out. Because what happens is when those bubbles are near the side and then you open the top, they immediately rush to the surface and they take all that cola out with it. So after seeing what just happened there, after a few shakes and after all of the stuff flying everywhere, that's the pressure and everything inside of the gas coming out, let's see what happens if I shake this can really, really good. So all you need to do is 6 taps. You could probably get away with less. Let me show you how to do it. You hold it up, 1 on the side, 2 on the side, 3 on the side, 4 on the side, 5 on the side, 6 on the side, and open. Certainly didn't fly across the room, right? That is science, ladies and gentlemen, in action. What happens here, we shook it up, the gas was inside there, it came out of solution, it's ready to explode as soon as you open this can, but by tapping the sides, we're taking all the bubbles that are stuck to the sides of the can, and we're forcing them to kind of detach and float to the top. So when we open it up, we do have a little bit of fizzing, but nothing like what happened here when we shot the cola all across the tabletop here. So, certainly you could try this if you wanted to and just sort of experiment with it, but really it'll come in handy next time you're unloading groceries and you drop a nice cold can of soda or something on the ground, and it bounces and dumps around and you don't want to open it because you're worried about it. Pick it up, tap it on the side 5 or 6 times, nice and firm, just kind of rotate the can, bam, 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 that detaches all the bubbles, they go to the top, open that can, no problem. And that's a really practical science lesson. I'm Jason with ScienceandMath.com. I hope you've enjoyed this. Go have fun with it and show people how you can open a can of soda, and more importantly, teach them why it works.